All right, so let's go ahead and get into multiplying fractions. Okay. Yes, there's some words here. We'll get into that in a second. All right. These area models kind of just show us how to represent multiplying fractions. Ultimately, what we need to know is when you multiply fractions, that you're just multiplying straight across. Okay. I'll show you what that means. So when we look at example A, we're multiplying straight across, right? So 2 times 3 becomes 6, and 5 times 4 becomes 20. But then you'll notice something's happening to that 6 and something's happening to that 20, right? They become another fraction, and that fraction is a little bit smaller. And the reason why that fraction is a little bit smaller is because we're simplifying. So you're finding a number that you can use for both numbers to simplify. And the number that we kind of have that we share between 6 and 20 is 2. So 6 divided by 2 is 3, and 20 divided by 2 is 10. So that's where that's coming from, okay? Let's keep working on some examples here. 2 times 3 would give us 6, which is fine. And that would give us 3 times 5 would give us 15. So now, again, I'm going to think about a factor here. And a factor is just a number that can be multiplied into these numbers, right? What is a number that both 6 and 15 share? I'm thinking 3. 3 can fit inside of 6 2 times, and 3 can fit inside of 15 5 times. So really, it does become further simplified from 6/15 to 2/5. Now, when you're multiplying fractions and dividing fractions, you're going to end up with improper fractions or proper fractions. But you still have to simplify. You always have to simplify, okay? And there are times when you can't simplify any further. I can't simplify 3/10 any further. I can't simplify 2/5 any further. I can't. But I can simplify 6/20, and I can simplify 6/15. All right, keep going. Again, multiply directly across. That's going to give us 5 over 24. Now, there are no common factors between 5 and 24. Nothing times 5 I can then use to multiply by another number to give me 24. It just doesn't work. So in that particular case, we only take one step, we multiply straight across, and we're done with our answer. If you look just a little bit further down, you're going to see that I've filled in some words, right? So in order to multiply fractions and mixed numbers, each number must be written as a proper or improper fraction. Mixed numbers must be converted to improper fractions, and whole numbers must be written over 1. Let me show you what they mean by that. So when they say a mixed number must be converted, let's say I have 1 and 1/2. So that needs to be converted. In class, we've been learning this trick called walk around Texas, even though it's an addition sign and a multiplication sign. So 2 times 1 is 2, plus 1 is 3. Our denominator stays the same, and we've converted it to an improper fraction because our numerator is larger than our denominator. And let's say that we were multiplying this by 5. Well, that's a whole number, and a whole number is always still just a fraction over 1. Okay, so that's just a quick example of what we mean by that. All right. So the steps for multiplying fractions: you change each mixed number to an improper fraction, you multiply your numerators, and then you multiply your denominators. So here on the bottom, we're just going to multiply straight across. 2 times 4 is 8. And 3 times 5 is 15. Neither of those numbers share a common factor, so there's not much else we can do there. We'll do it again down here. 6 times 2 is 12. 7 times 7 is 49. Again, there are no common factors here. These two are good examples of what I said earlier in terms of some fractions. All you have to do is multiply straight across, and there's nothing else you can do to simplify. But you should always try to simplify. Okay, let's go to the next page here so we can work on some examples. Now, common factors between the fractions can be... Sorry. I'll fill that in too. Simplified. Okay, and I'll show you what I mean by that as well. Sorry, it's going to be all messy because the paper's popping up. Simplified. So, yes, you can multiply straight across and then simplify. Okay, that's perfectly fine. But what you can also do is look for what's called common factors. Okay? Common factors, again, it's a number that can be multiplied or divided into another number. The only difference here, I would say, and it's a fairly big difference, is that when when we simplify, we're always simplifying our numerator and our denominator. Our numerator and our denominator. But when we find common factors, well, I'll start with this example here. When we find common factors, we're actually trying to find those common factors diagonally. Okay? So let me show you what I mean. A common factor between 3 and 3 is 3. Well, 3 can fit into itself once. Here, our common factor between 2 and 4 is 2. 2 can fit inside of itself once, and 2 can fit inside of 4 2 times. So now we've already simplified our fractions, and we just multiply straight across. 1 times 1 is 1. 1 times 2 is 2. We end up with 1/2. If we don't do that, we'll still get the same answer. It's just sometimes easier doing the simplification first. So if we multiply straight across, we end up with 6 over 12. Perfect. But again, we have to simplify that. I know 6 and 12 share a common factor of 6, and 6 can go to itself once, whereas 6 goes into 12 twice. Ergo, you get the same answer. Only difference is here you simplified first, and here you simplified second. Okay? So, let's go ahead and put that into some practice here. Okay. So, common factors that I'm going to see immediately in number 4 is 4 and 4. They both fit into themselves one time. But I also see another common factor. And that common factor is 3. I know 3 can fit into itself once. And I know 3 can fit inside of 9 3 times. Now, since I've already simplified, all I do is multiply straight across. 1 times 1 is 1. And 3 times 1 is 3. Therefore, my answer is 1/3. When we get to number 5, we have two mixed numbers here, and in order to multiply or divide a mixed number, we have to turn it into an improper fraction. So, the strategy that we've been learning in class has been walk around Texas. So I'm going to rewrite my fractions. I'm going to give it a little bit of space. Perfect. So, I'm going to walk around Texas. 2 times 2 is 4, plus 1 is 5. My denominator stays the same. I'm going to walk around Texas. 5 times 3 is 15, plus 3 is 18. My denominator stays the same. So now I've set it up pretty well. But now I'm going to look for those common factors, okay? So I see a few common factors here. I see that 5 can fit into itself once, and 5 can fit into itself once. I see that 2 can fit into itself once, and 2 can fit inside of 18 9 times. So now when I multiply straight across, 1 times 9 is 9. 1 times 1 is 1. You could write this as 9 over 1 or just 9. Okay? Cool. Let's keep going. Looking at number 6. Okay, a recipe requires 2.5 cups of sugar. If Mrs. Marina is going to make 1/2 of the recipe, then how much sugar does she need? Okay. Alright, fine. This one isn't too bad either, but we're going to write our mixed number there. We're going to end up multiplying this by 1/2. So let's go ahead and walk around Texas here. 2 times 2 is 4, plus 1 is 5. 5 over 2, because my denominator stays the same. Here I don't have any common factors, so I really just have to multiply straight across, and that's fine. So I'll multiply straight across, and I'll end up with 5 over, let me rewrite that. 5 over 4. Well, that's still an improper fraction, and I can't do that. Okay, so I have to ask myself, how many times can 4 fit inside of 5? Answer is once. Here, I'm going to bring this over here. Okay, remember this number, 5/4. That way it makes more sense and it's not all scattered. Okay, sorry. So 5 over 4. 4 can fit inside of 5 one time. Okay. Our denominator stays the same. And if 4 times 1 is 4, and we had 5/4, then 5 minus 4 leaves you with 1. This is our answer here. Okay? So, how much sugar would she need? She would need 1 1/4. Okay? So yeah, cool. Let's keep going. All right. Number 7 says a rectangle has a height of 1 1/4 inches and a base of 5/6 inches. Okay, perfect. So first thing I'm going to do is when they say I have a rectangle, I'm a visual person, I'm going to draw a rectangle. Has a height of 1 1/4 and a base of 5/6. Okay. What is the area of the rectangle? Well, also, what's super important is to know what our formula for area is. Area is equal to length times width. That's super important because that's going to tell us what we have to do, which here is take our 1 1/4 and multiply it by our 5/6. So let's do that. We have to convert. We'll walk around Texas. Okay, so that's going to look like 4 times 1, which is 4, plus 1, which is 5. We have 5/6 times 5/6. When we multiply that, we get 25/36. So we'll do 25/36. Well, let's see, we can't truly simplify this, but what we can do, wait, no, I think that is all we can do, right? 25/36. that is going to be our area, which is a little crazy, but it works. No, wait, because I did 5, 6. That's why. Okay, my bad. This should have been a 4. I knew it was weird. Okay. So it's 25 over 24. My bad, y'all. Now, I know 24 can fit inside of 25 one time. Our denominator stays the same. And if 1 times 4 is 24, and 25 minus 24 is 1, then this here is my final answer. The 1 and 1/24. My bad about writing a 5 there. I made a mistake. Remember, your denominator should stay the same. Even though I had that written down, I still made a error. Okay, so that's my fault. Alright, let's keep on keeping on. Okay, we have to figure out what's true and what's false here. It says 4 students were each given a card with a fraction on it. Then they were asked to pair with another student and multiply the fractions. Okay, so basically we just need to figure out which ones are true, which ones aren't. Okay. It says when Omar and Andre multiplied their fraction cards, they got a product greater than 4. Okay. Sorry about that. So they said a product greater than 4. So our answer has to be a number that is greater than 4. Alright, what names did they say here? They said Omar and Andre. Okay. Here's Omar. And Andre will be 1 5/6. Alright, well, let's go ahead and do our walk around Texas and convert. 4 times 1 is 4, plus 3 is 7. That's 7 over 4ths. We'll swing this around. 6 times 1 is 6, plus 5 is 11. This should be 11 over 6. Okay. I don't see any common factors that we can simplify diagonally. So if we multiply straight across, we should end up with 77 over 24. Okay. Can't leave it like that, obviously. So let's take this 77 divided by our 24. What is it? 24, 48. So it should be able to go in at least twice. 48, 6, 17, 9, 2, decimal, 0. Wait, no, I don't need to do that yet. 24 goes into that one time. 24, 5, decimal, bring it down. Still just kind of twice. Okay, well, so they're ending up with something like 21.2 is when Omar got, and they got a product greater than 4. So obviously 21.2 is greater than 4, so that statement is true. Cool. Awesome. Yeah, I'm not going to continue on and on and on and on. I already know if I have a number on the left side of my decimal, that's a whole number. And if that whole number is greater than 4, then I'm okay. If I look at B, it says if Ira multiplies her fraction card by any of the other fraction cards, the product will always be less than 1. Okay. Ira. Okay. Let's do it, Ira. Fortunately for us... Oh. Well, let's justify this one. 77 over 24 is, I'm going to say greater than 4. That's fine. I'm just going to show my work in here for Ira. Ira multiplies her fraction card by everything. So Ira is 1/5. Since we've already converted Omar and Andre, Omar is 7/4. Okay, no common factors. That's going to be 7/20. 7/20 is not greater than 1. So far that's, I guess, right. Let's see. Andre was 11/6, so we'll do 1/5 times 11/6. That's going to give me 11/30. That's also less than 1, so far so good. I think the only one we need to convert is Ellie. So let's go ahead and do that with a little walk around Texas technique. 7 times 2 is 14. 14 plus 2 is 16. 16/7. So Ellie is going to be 16/7. Let's work that out. 1/5 times 16/7. No common factors. Multiply straight across. We end up with 16/35. Again, that's also less than 1. So when we matched up Ira against Andre, 7/20, that's less than 1. Ira against Omar, or that's Omar, that's Andre. 11/30, that's still less than 1. And then Ira against Ellie, 16/35, that's less than 1. So in this particular case, I'm going to say that her statement is also true. Let's look at C. It says, when Ellie and Omar multiplied their fraction cards, their solution was between... Okay. It says their solution... Let me get the other color. Stays consistent. Their solution was between 2 and 3. So it has to be a number between 2 and 3. Otherwise, it's going to be false, okay? It says when Ellie and Omar. Okay. Ellie and Omar, where are we at? Ellie, we have 16/7. We already did that, so we don't have to do it again. And Omar, which we did earlier here, is 7/4. Ooh, good. Excellent. This, I see some common factors, okay? Hopefully you see them too. First common factor I'm going to see is 4. Well, let's do the obvious. 7 and 7, okay? 7 can go into itself once. 7 can go into itself once. Then 4 and 16, the common factor there is 4. So 4 divided by, or can go into itself once, and 4 can go into 16 4 times. So when you multiply straight across, you end up with 4/1, or like I said earlier, just 4. Now, is the number 4 between 2 and 3? It's definitely not. So in this particular case, that's false. Alright guys, hopefully that was helpful in terms of multiplying fractions. And yeah, I'll work on the next video.